All right, let's hop right into this today. So this is Linux Security Engineering Unit 3. We are going to run through and talk about some of the different components of security engineering and how they relate to locking down our Linux systems, right? So let's just begin. And this is a recording that goes along with a course. You should have probably found it through our playlist on it. So if you have any questions, just join us down in Discord and we'll try to answer them for you. All right, so this is our third meeting. If you have any questions, feel free to ask down in Discord. We do have an upcoming event I'd like to let you guys know about. It's August 9th and 10th of, 2025. And we're going to be doing just our normal meeting that has to do with all of our systems engineering. Give me a second here, guys. Hold on. I gotta fix this. This is bugging me. I gotta fix this. I don't know why that's like that is. Alright, well, we'll be alright. So, this is our course, and this is what we're working on. So, last week, what did we do last week? So, in our week 2, the entirety of the course, we've been doing STIGs and knocking out compliance for systems. But one of the things I've really been trying to emphasize, and one of the things that's really important as you guys are getting into security engineering, is it's not just about blindly hitting buttons and following STIGs. That is not the point of security. The point of security is to knock out those things and lock the doors and that kind of stuff, but also to understand the purpose of why you're doing it. Because sometimes, we lock the doors and we protect a system to a certain level, but we also want to understand if there's trade-offs. What are we giving up by doing that secure thing? What are we giving up by doing a certain password complexity requirements? We don't want to just blindly follow rules. We want to understand what the rules are so that if we need to move and change things, we can, because we understand what we're doing. So that's an important thing. Last week we were talking about STIGs and their focus specifically around networking. We talked about how networking is the pipe that allows data to flow into our system. No Linux servers that have ever been built have existed in a vacuum. Well, no useful ones. They have to be connected to a network. Data has to be allowed to flow in and out of them. Then we talked a little bit about DNS and name resolution. Are we doing local resolution? And what are the problems with that and the security around it? And all of these discussions are up in our Discord because we do our discussions publicly. We talk through the different items in our course. There was a worksheet for last week, and then we did a lab on network standards and compliance. So that was last week's stuff. We had some additional killer coda labs that you could go spend time with and just get more immersed in the process of stigging a server, right? So this week, we're going to still be doing STIGs, right? We're doing these STIG compliance things kind of the entirety of this, but we're going to be dealing with PAM, which is the pluggable authentication modules in Linux, right? So we're going to talk about PAM and how that works. We're going to have some discussions back and forth around that, and then we'll talk a little bit about SSSD and how that allows our system to integrate with Active Directory or OpenLDAP or whatever is our authentication in the system that is a trust outside of just our base Linux systems, right? We want to expand past just doing local authentication. Local authentication is not a great look in the Linux world, right? It's difficult to maintain. It's something that would be out of date very quickly. We want to use a centralized authority and allow people who are engineers in that space, the identity and access management engineers, to deal with that kind of stuff. Simply put, on the Linux side of things, I don't want to be in the business of dealing with the users, right? I just want to give access to my systems and that kind of stuff. We got a worksheet this week. There's a worksheet every week. And then there's a lab on identity and access management that you can complete in the ProLUG group, right? We have a set of lab servers, 25 Hammer servers that you guys can use. So overview, could have sworn I just updated this. But anyways, how do we secure our network, but specifically the ingress point and the user identity? What are the relevant STIGs and the relevant tools that are going to help us with that? We're going to set up OpenLDAP on one of our boxes, which I'll note at the time is not the type of thing that we tend to do as Linux engineers, but we're going to do it just so that we have a place to put a user, and then we're going to connect to them and validate that we can see that user identity. Once we have that, we would be able to start troubleshooting OpenLDAP and SSSD and doing our different STIG compliance type things if we wanted to. And then how do we report this out? I was telling you guys this is 100% true. There's never going to be a time in your career where, like, you're not anymore, maybe 20 years ago, but not now, where you're going to like secure a Linux box and then somebody's just going to come by, some manager's going to come by and be like, are we good? And you're just going to be like, we're good. And then they're going to walk off. That doesn't happen. What's going to happen is they're going to say, we need to report up to our governance, risk, and compliance team. We need to report up to our risk management team. We have to have our security posture, but then we also have to report it up. So part of the STIG viewer and the STIG tool that we use is the ability to have a standardized way of pushing that up. Okay, so reporting that out as we do this kind of stuff. So that's what we're doing. Let's get into the actual course then. Let me pull up. This is our worksheet for the week. Let me pull up the, what is this here? That's our security project. We need to look at that. And then we also need to look at the lab for this week. So I'm also going to pull up a terminal, right? We're in a terminal. I am in the Hammer 25 server. I'll maybe do an ID and a who to make sure that I'm the only one on the server. So that looks correct. And to start out, we start out typically with the worksheet. Let me show you the little worksheet here. And in the worksheet, it gives you kind of instructions for the week. If anybody ever gets lost in the course, you can always pop on Discord and go right to our ProLUG project section, and that has everything that we're working on for each of the weeks. So this is something I try to tell you guys to go spend some time in there and make sure that you have a knowledge of what we're doing for the week. All right. So anyways, we come back over here. There's 2 discussion questions for this week. The first one deals with Rocky Linux and the or RHEL, which is Rocky's just derivative of it. And there are 16 STIGs that involve pluggable authentication modules for RHEL 9. Read the guide here. So we have a guide on this. Where's that? Right here. And the guide is how pluggable authentication modules work. In specific, there's 2 things. There are mechanisms, which are right here, the directives, and then the mechanisms. Authentication, which is auth, account, session, password, required, and requisite. And then there are also the common PAM modules, which are down here. These are common PAM modules that get called out of your pluggable authentication modules. So if we were on a Linux box and we were looking at this, we can cd to etc pam.d. We could cat our SSHD. And here are a bunch of these that determine when we go ahead and SSH into a system and we pass a hash of a password. You know, you put in a password to your client saying you want to connect. You're going to send a hash of that password across the network, and then pluggable authentication modules are going to go and they're going to validate that against what is known for your password on system or whatever type of authentication method you're using, right? The SSH daemon does not have the authority to go look at those files, right? Nobody has the authority to look at those files, right? They are locked down. Only the pluggable authentication modules can access those. Well, the root user can look at it as well, but that's only because root's root. But anyways, we have the authority to do that, and the pluggable authentication modules define how your process has to interact with that. All right, so at a high level, that's what we're doing here. So we come back over here, and then we say, there's some questions that deal with, you go and look at this, what is happening in that file relative to these functions. So you just kind of map this around, and then you find out what you understand about how SSH interacts with your system. Then we talk about the common PAM modules and the same kind of thing. And then one of the things I challenge you guys this week in the discussion is to say, hey, look here for a blog post or article about pluggable authentication modules that discusses it in a real world application, right? And then post it here, give us a quick synopsis. And then I said bonus points if you find one of our ProLUG members who actually has blog posts about PAM. So if you can find him, post that down in the discussions. That's kind of a nice thing. I know his blog comes up in the top Google searches if you look for pluggable authentication modules. So that's discussion post 1. Discussion post 2 deals with lightweight directory access protocol, so LDAP, And we then can go and look at how LDAP works with our system, which is right over here. And you can just really quickly find some information out about it, and then I ask some questions about LDAP in your system. All right, so that's the questions for the week. The other things that you get out of the worksheet are some of the definitions and terminology that you're going to run into. And these are the things that you might want to know and go learn a little bit more about. Maybe you've never read about what odd job is, and you're like, that's some application, I think, but I don't know what it does. And you can go read a little bit about it. What is realm and realm D, and what is wheel in relation to systems engineering, right? And specifically security and pseudo inside of Red Hat systems, right? There's a bunch of notes and lectures and a bunch of other places to go look for information. So I put those down here, and then tools that you're going to use, and then your lab assignment down here. I always give a little digging deeper section. These are not required for the course, but they can just be a place that you'd go spend more time if you wanted to, right? And then your reflection questions. What questions do you still have, and how are you going to apply this? These are the things that we need to think about as we learn stuff in a system. Okay, so we're going to move this out of the way. And then we're going to go back over here, and we'll get these out of the way because those are just places for you to reference. And another thing that's going on this week is we've got the final security engineering project. There's a project that goes along with this course. It's a 10-week course. And if you do want to complete the course, you do have to do this project. And it says here that we've picked up a new client. They're requesting that we help them adhere to the HIPAA compliance standard. All right. What the heck's a HIPAA, right? I got to go figure that out now. And then review this explanation here. This is a really good kind of breakdown of how HIPAA works and what the security rule means. But it deals with how your system, how your IT systems handle data if you're doing public health information, PHI, right? Or personal health information, PHI. So they talk about the security rule, how we protect the information. They give you some general rules, and then more specific things that we do. So I distilled some of that down into some documentation that we're going to build. We're going to build some documentation about risk analysis and management. How are we going to keep track of risks in our system? Well, one way to do that would be to harden the systems, and then maybe have a vulnerability management program, and then compare that to maybe like some kind of risk profile. And there's applications and software that does that, but at a high level, we just need to understand that we need a risk analysis and management program, right? We need to be improving stuff. Then down here, what are our safeguards? What are we doing on the Linux side to prevent the administrative, physical, and technical? So these are types of controls, and we've learned about these so far in the course. Administrative breaks down into managerial and operational, right? But physical controls are how do we physically stop things, and technical controls are how we technically stop things, right? And then there's different levels of access on this. How do we form business associate agreements? I don't expect you guys to dig too deep into that in the project, but at least understand that we need a reciprocal agreement in HIPAA before we send data anywhere. And then once we have that, the assurance that the other side's also going to protect the data, then we've entered into an agreement and we can share data, right? And then this is a big one. What are our documentation policies? I think we should have 5 policies at least at a minimum. And then what are our procedures? How are we actually securing the system? What are our different procedures? And then what's our update and review cadence? So I'm going to build an example one of these because I have to do a project like this for my real work anyways. I have a customer that does HIPAA compliance. So I'm going to be doing this as well, but I want you guys to think about this. Also, people in the EU asked, can we do GDPR? And I said, absolutely. Yeah, GDPR, I don't know the rules nearly as well as I know the HIPAA rules, but I think you guys could absolutely do that if you wanted to. You'll just be changing your documentation some. And then I challenge you to go and go to a tool like Overleaf, which is a free, you can get Overleaf for free, but also the open source part of it, you could run your own version of it, and set up a little slide deck with Overleaf, right, of your project so that you can describe it. Some of you guys can present if you want in the later weeks, if you guys want to do that. And then here's the deliverables, a 15 to 20 slide presentation on the material above, right? So that's what you're doing. If you're, now, anybody can follow along with the course and not do the projects and not do the discussions. I should really emphasize that. You guys can do whatever you want in life. But if you want to finish the course and get the little certificate that we're giving out, you have to do all the work, and it's probably a couple hundred hours worth of work if I had to guess, all the stuff that we're doing. So, all right. Anyways, that's that. Let's get into the lab, right? So the lab is kind of it's actually funny. I didn't have the lab finished yesterday when we met, so some of the guys that are doing the course with us, if they're watching this, they're seeing the lab for the first time, which I think is kind of funny. And by the way, if you are doing the course, everything is in our Discord, and it's all in the ProLUG project section. In fact, you see all these threads? These are all the threads of people responding to different questions from the first 3 weeks, because now we're in week 3 of the system. Discord is here if anybody needs it. You guys are welcome to go join the Discord and go look around in there. There's a lot of people to help you with that. And if you're doing either of the courses, we are publishing. There's a book that's published online for free that you guys can get a hold of as well. It looks like this. If anybody needs, where's that book at? This is the security. This is the administration course, but there's a security one as well. I don't know where it's went, but. All right, that's all we need there. Let's get into the lab. I just rebooted the server. It's mine. I'm the only one in it. And we're going to do some identity and access management. And down here, there's some warm-up exercises. So maybe I say ls-l etc pam.d, and I say, look at the permissions of this. And what do you notice about the pluggable authentication modules? Well, anybody can read them. There's no protections. There's nothing stopping anyone from getting into that directory. That X means you can traverse the directory if you're anybody. And up here, 644 on all files means that anybody can read them. All right, so we know that. And then maybe I go look at cat etc pam.d sshd, and I look for, is there anything in here that makes sense to me? Is there anything here that I understand from like a system standpoint? And if I don't, that's fine. I can go read about it and learn about it as we go through. But I just need to start getting familiar with these, right? By the way, and I often tell you guys this, if you get into app development on Linux, you are not going to be able to access the authorization of the local system directly. You have to learn how to use the pluggable authentication modules, but once you do, you can write all the applications you want, and then your application just references those, right? It's exactly the same way that all these other things work right here. All of these different tools that exist. All right. Looks like I didn't finish that as much as I would like, but that's fine. All right. Then I tell you guys, this is the same thing we've been doing the whole time, so hopefully this is review for some of you. But download the STIG viewer from the government. And I still use version 2. You can go to version 3 if you want. It's got a better dark mode, I guess. And then download the STIG for RHEL 9. And I've walked you guys through that before, so we're not going to look at that as much right now. But suffice it to say, you should be able to pull up a STIG viewer and then see all of the STIGs. There's 401 of them for RHEL 9 on your system. So I am looking at the STIG data for Red Hat Enterprise Linux 9. That's it. So what I can then do, if I move this over here for now, is I can go through the course here and start to look at, I connect to a Hammer server, and I filter by PAM, so that's pluggable authentication modules over here, PAM. And how many STIGs do I see? I see 17 STIGs right here. But it says, why is it really only 16? Well, if we come up here, start to read through them, the first one is spam. It actually deals with redirect. So if unrestricted mail relaying is permitted, authorized senders could use this host, and we can stop that from happening right here with a postconf if we're running postfix in our environment. We're not running postfix, so we don't care. But there are truly 16 STIGs that deal with pluggable authentication modules, and they start right here. So come down here, and I say go to 257.986, and here is the pluggable authentication module interface for SSHD, and it says when PAM is set to yes, PAM runs through this. So one of the things I ask over here is it set on your system? So we do a grep-i against etc ssh sshd underscore config. Oh, never mind me. grep-i of PAM, right? We want to see if PAM is set. And the default setting is no, right? It's commented out, use PAM no, but that means that that's the default. Well, that means that I can't say that this STIG is actually good. My finding details if I were filling this out for an actual report, would be right here. There's my finding details. And I'd say this is not a pass, right? And then I would right click on this and say this not reviewed thing is actually open and it needs to be addressed in some way on our system. That's what we see right here. That's what our net effect of this is. It says what type of control is being implemented, how is it set on your system? Can you remediate the finding? So could I set use PAM to yes? Absolutely, I could do that. I could VI, Etsy, SSH, SSHD, right? And then I can go to PAM. And I can change this right here to use PAM. Yes. And then all I have to do is systemctl restart SSHD. Now, is that last part important? Absolutely. You're not actually making a change until you've done that. But now I can grab this, right? This is now the output from this. And I could come down here and say, well, that's what you would find, right? That is actually what you'd find now. And then this is a pass. And then I would right click and I would change this to not a finding. Now, some of you are very quickly going to note that's kind of tedious, right? I've got 401 things and I have to go through and check them and knock them out and stuff. Well, that's why we have these scanning tools and some of these other things that generate these checklists. And that's from what we were doing last week. But for us on this week, we're manually fixing a few of them. But normally we would want to run like an SCC tool or an automated scan that will populate a checklist for us. And then that'll knock out a couple hundred, maybe almost 300 of the 401, and then you only have to go and review some of them or remediate and fix some of these. So I have fixed that on this system. Some of you guys know that our Hammer servers they don't persist through reboots, so that didn't really fix anything, but that's fine. Now the next one is check and remediate STIG 258055. So we're still in here, 258055, and this one says RHEL 9 must automatically lock the root account of the root account if the administrator has 3 unsuccessful login attempts. I go, huh, that's interesting. That's what I have to do, right? That's my requirement. And I go, well, I said earlier that this isn't just about blindly following rules and turning things on. I need to think about that for a second. Do I really want my root user to lock out in a system or not? This is something you might need to think about as a sysadmin. There's some decisions to make here about, it's possible that we're going to eat this one and say that we're not doing this, right? And that's not really how you'd write it up. Typically for your security team, especially if you're dealing with like government people, which are called ISSOs, Information System Security Officers, in your organization you might have a different policy of how you work with them. But typically what we might say is this would prevent operational activities not applied. And then you have to eat it, though. This is the problem. You have to leave it open, and you will lose the score. So your overall goal here in the STIGs is to get this score as close to 100 as you can. Well, you're not going to get to 100 because you're leaving one open. But you understand that we are, we're doing that. We're not doing the root lockout for a reason. And we don't want somebody else to just be able to lock root and then us not be able to get in. But also we understand that we have other mitigating factors. One of the mitigating factors here, I'll show you guys. This is one I do in my home lab. Some of you guys have been around long enough to know how my Bastion system works. But I have, if we just VI or just Vim, Etsy SSH, SSHD, I have root login and permit root login, prohibit password. In my system, in my home lab system, permit root login is set to no. So it's irrelevant what's happening via remote login because root can't get in even if you want it to. All right, that's a technical control, right? We talk about technical controls, and that technical control is overriding a different technical control as a mitigating control, right? That's kind of how that would be written up. So in my thing, I could say this would prevent operational activities not applied. We have a mitigating technical preventative control of no root logging in remotely, right? And then that would be acceptable for most teams to say, okay, that's good. Yeah. That is within our risk profile, within our risk appetite, whatever the thing is that we're saying for that time. All right. So hopefully this is kind of making sense to you guys that what we're doing is knocking out the STIG values, knocking out the things that are out of compliance in our system and making our system more secure. But we're not just blindly doing it. We're doing it in a way that applies and makes sense to us. All right, it makes sense to us from a security standpoint. So 2598 right here. And we come in here and we say, do we understand the PAM password quality? And if we use password quality, then we can enforce password complexity rules. Okay, that's fun. So now I come over here and I go to my filter panel, and I'm going to remove the filters, and I'm going to say password complexity. And one of the things you're going to do is look at all the password complexity rules that exist, right? And down here it's password complexity. So you have to have a lowercase. You have to have a, this should be a numeric character. Yep. You've got to have a minimum length of 15. That's fun. You're going to have a O, which is the other character, right? Where's that? Yeah, special character, right? So any of the shift number keys, right? You're going to have it can't be a dictionary word, so it's going to check it against dictionary words. It can't be, you got to have an uppercase, so you have to have an upper, a lower, a digit, a other character. It can't be a dictionary word. And then one of my favorite ones is coming up. This one's just dark. This one says at least 8 of the total number of characters are changed, but from the last one, so that one's fun. And then this one here, max class repeat. You guys ever heard of this? I had never heard of this until I started doing STIGs. So let's say I said the word, like I don't know, I had Thomas in there, capital T, H-O-M-A, that's it. You can't have another lowercase character in a row. 4 of the same class in a row. This one gets super annoying because you try to add some numbers, you try to do, a word, or like people talk about key phrases and stuff. Nope, not unless you're adding caps and lower cases, like you're doing one of those, you're making fun of somebody on the internet or something. Yeah, you can't do it. It doesn't work. So, yeah, there's other ones too. Here's the max repeat. Yeah, how many times can the thing repeat? So that's 3. I thought it was 3. Yeah, the 4th one is a fail. And then minimum class, so you have to have at least 4 of each one. Right? They're ridiculous. They're like that password game that just keeps getting more and more complex. But you could, strictly say that you're not going to adhere to certain ones and then have a reason why, and that's a possibility. But again, we're not just blindly following them. We're understanding why they're there. All right, so then we get down, and I keep asking you more. Filter by SSSD, so you go and you look at all of your SSSD. But you need to remove all the other filters first. And then there's 4 for SSSD, which deal with how we authenticate over into like an Active Directory type system. All right, so that's the first part of the lab. The second part of the lab I didn't have done yesterday, so I'm going to show you guys this. I spent a little time last night getting it up. So the first part of it is you're likely not ever going to build LDAP in your career. That's probably not going to be most Unix engineers building LDAP locally. But you are probably going to interact with LDAP from the second part. So for us to do that, I had to set up an LDAP server. So you guys are going to do a little LDAP setup here. So we start on the Hammer server, and the first thing we do is we have to stop the client. The reason we're stopping the client is this. In our cluster, because they're headless nodes or stateless nodes, they go down, they come back up. They are constantly pulling what we call runtime overlays, which reconfigures the system in real time. We can't have that happening because we're about to change the etc host file, and if you change certain files and then the system comes back, we're also going to change etc. So etc host and etc passwd would get overwritten. So we're just gonna go ahead and stop that right off the bat. So we stop that, then we're gonna VI our etc host file, and in here we're gonna look for the number 25. And we're going to come to hammer 25, and we're going to add a couple lines so that the system understands itself as being ldap.prolug.lan. and then also LDAP. Those are the two names that it's going to get. All right, that's all you got to do there. That is so our system identifies itself as both the LDAP ProLUG LAN and also as the LDAP in the system. Then we're going to go grab some DNF commands. The DNF commands are going to set this other repo inside of EPEL or inside of Rocky, and then we're going to install OpenLDAP. Now, OpenLDAP was deprecated in RHEL 9, so RHEL 9 isn't supposed to actually run it anymore, and Rocky is the same way. That's why it's over in the plus repos. But we're just going to go ahead and run it anyways. It's not a big deal. We understand why we're doing it for the lab. We understand that in the Linux world, we're probably actually going to get this from Active Directory, so that's fine. We're just gonna take it, just take it on the chin, as it were. We're just gonna do the project and understand that. So this is gonna install. And the next thing we're going to do is we're going to start slapd. So ss-ntulp, I do not see any LDAP type stuff running. And then system ctl start slapd. It's such a funny set of commands. And now we see the regular slapd running here. That's this. And then the secured on 636. So 389 is the default LDAP. And then the secure LDAP is here. Now, the next part I'm going to do, strictly speaking, isn't needed because we're only going to be communicating as both the client and the server on our own machine. So the firewall actually never comes into play. But we're still going to set the firewall as though we were connecting from a different machine. So all we're doing is allowing LDAP and LDAP-S. And then we're going to see LDAP and LDAP-S. And if we wanted to go inspect what those are, we could go down into var... what is it? Var lib firewall. What is it? No, user lib firewall. Yeah, and then in here, if we were to go in here and go to services, then I could more LDAP.xml and LDAP-S. If we just wanted to see those definitions, we could, but we don't need that for the lab. It's not in the lab. And then the next thing we're going to do is we're going to do a slapd password, right? And this amuses me to no end, but we're going to make a slap password. And the password we're going to use is test password. If I could type it right. And then we're going to go ahead and grab this and keep this for ourselves. I might even go throw that in a notepad so that I have it, right? But then we're going to come down a little bit, and I'm going to change the password on the system. So I'm going to vi a new change root pass.ldiff, and I'm going to come down here, and I'm going to grab that, and then I'm going to grab all of this out of our lab, drop that in, pull this back, and then this is how we're going to run this to do the initial authentication. Here's the command right here, LDAP, to run this LDIF. I'm going to show you guys something here in a second as well. So that'll do, and it'll say authentication started, and it took that. All right, good. Real quick, if you're like, that's a lot of commands and I don't want to write all that stuff up, there is in labs, I made I think it's in lab work actually. In lab work, there's an identity and access management tar GZ. You could pull that down to here. You could pull it down to your system. Here, and then you could tar-xzvf identity, and then you would have all of those files if you didn't want to go and pull them out of the lab. So I gave you guys an option for that, but I'm just going to make them as I go. And that's a perfectly acceptable way to do it. So we've got that going, and now I'm going to generate the basic schema for my system. So I'm just going to run all these over here, right? And then I'm going to come down here, and I'm going to set the domain differently in my system. And before I do that, I'm going to go capture one other thing. That slapd password that I did from earlier, I'm going to grab that password again because I'm going to need that here in a second. All right. So we're going to then keep coming down in the lab a little bit, and we're going to make a new one to set up the domain. So vi set domain.ldif. And in here, I'm going to need this password. So I'm going to just go ahead and take that and move that down a little bit. And then we're going to copy all of this. All of this right here. Boom. For our system. Now, we're going to need this password. So I'll just grab it like this. It's fine. We're going to need this password set right here. So escape $$ will delete to the end of the line, and then just right click to drop that in, DD, and then we'll DD the bottom of this out. So that is, you know, essentially just captured right out of our, you'll get this as a PDF if you grab it out of the Discord. So we come down here and we right quit, and then we're going to modify this set domain. We're going to run this into the system. And when we do it for this first time now, we're going to need that test password. We should be able to validate that the domain is working here. There we go. So we see the DC of ProLUG and the DC of LAN. So it's prolug.lan. Perfect. And we're going to scroll down a little bit, and we're going to now add some groups and organizations to this. So vi add ou.ldif. Again, you could just go, if you don't want to write all these out, you can go copy these. We need this one right here. Escape :WQ or Shift ZZ, whatever you guys want. And now we're going to add this to the system. But this is where we need the password. So what's our slap password? It was test password. And if that works, it's going to add that in. If you did anything else wrong earlier, it's going to break all over the place and tell you bad credentials, and then you're going to have a bad time. So then we come down here, and there's some commands we can do to kind of search this and verify that everything works. I can run these commands here if I want, and I'll just see information about the working LDAP in my system. I can do each individual command like this and just see that I now see those people and group and all these things in there. Now, I don't have any users yet. Again, as we're doing this, I want you guys to think, I'm glad I don't do this. This is identity and access management crap. That can come from Active Directory. We're going to be doing the second part of this lab normally as our career, but this part is just us working through. So, all right, we're going to make another password. Slap pass WD. It's such a dumb command name, but test user 1234 is going to be my password. Test user 1234 is my password, and I get this cool little, that is a salted hash. So the first 4 characters are the salt, and the last 4 character, or the rest of it is the actual password against that salt. Now it's weird because you're going to say, well, that's weird. Watch this. I'm going to do the same thing, and I'm going to do test user 1234 and then test user 1234, and that's a different value, but I use the same exact password. And you said, well, which one of these is right? Yes, they're both correct. Either one of these would work for that password because it's salted. So what that means is we've made a password that could technically sit safely in a config file, and nobody would still know what the password is without knowing what the salt is, right? All right, anyway, so let's go down here. Let's vi our add user .ldif. Don't worry, we're almost done with the part that we don't normally do. I'm going to just go ahead and add that there so it's out of the way. And then it's just because I only have one paste buffer, basically. And I'm going to go grab all of this for my user, and I'm going to drop my user in here. Now, I got to grab his password, so here. Come up here. $$ will delete to the end of the line, right? And then we're going to drop in that password. Make sure you have it formatted correctly. You do need the curly brackets around that. Okay. Escape :WQ. When I look at it, the user ID is 15,000 because I just wanted something out of the way that wasn't going to conflict with our normal system. Cool. We can cat that file anytime we want. There's our add user. Login shell is bin bash. Home directory is home test user. 15,000 is his UID, GID. We just wanted, again, something out of the way. So now I've got to add that in. So I'm going to add that in here, and I'm going to need credentialed access again. So this was what, test password, and then now we've added that user into our Active Directory. I should be able to search for those users now, and the search is non-authenticated, right? But there's our user in the system. Cool. It sounds good. Now we verified that that's there. Now we're going to secure the system with TLS, but we're not actually going to worry about the TLS in the big scheme of things. But if we needed to, we would generate a certificate. You can just accept all the defaults. I think I say right there, accept all the defaults. And you could add information, but a self-signed cert isn't as secure as a cert that you get from somewhere, from a trust authority, or what we call certificate authority, for all the normal reasons. But internally, it works just fine. It's actually perfectly acceptable. There's nothing wrong with it. It's just you have to establish that trust yourself. So we're not going to worry about that. The last week of our course, I actually have it entitled Certificate Madness. We're just going to do certificates the last week. And then some of you will go back and go through some of these labs and be like, oh, okay, I understand a little better how the certificate part of it works. But now we're going to do another thing. We're going to vi tls.ldiff. And in here, we're going to add these values to now use the certs. Oh, I also say you can go look at the certs that you created if you care. There's a public one that everybody should be able to read. And then there's the private one, which is your LDAP server key that nobody should ever see. Okay. We're going to add this, escape : WQ, and then we're going to read that into the system. So now our system is using TLS, right? So there it is. A few things we're going to change. We're going to VI our Etsy OpenLDAP, LDAP.conf, and in here, we're going to change some things here. I'm going to fix these as we're running. Now I'm going to go a little ahead, and then we're going to change this right here to be, here's the value right down here of Etsy PKI TLS, and then LDAP server.crt that we just made, and then we have to add this line TLS rec cert never. Now these things that I said I was going to fix up here, I'm actually doing something from later, and I'm just going to add these two things in right now. We were going to do them later in the lab anyways, but I'm just going to save myself the time and do them now, because this server is acting as both the server and the client. So I'm putting the client portion in there now, which, by the way, that points back to ourselves. So anyways, all right. So that's that. And the last thing we should do is system restart slapd. And if that all works, then systemctl restart slapd. All right, we did the first part. We built an OpenLDAP in our system, and we never look back because, again, that's not really something we're going to do in the Linux world often. So don't worry about becoming an expert in that. That's not the purpose of this course. Purpose of this course is much more around SSSD can connect to a trusted LDAP system that you're going to get from your organization or maybe your identity and access management team. And then let's do that part. So we're going to make sure that we have all the tools that we need. So DNF install OpenLDAP clients, SSSD, SSSD LDAP, and we're going to say yes. And one thing I'm going to advise, especially if you're doing a lab for the first time and you're just, you're a sysadmin, but you're wanting to get a little better at some of the security side of the things, but you understand kind of how a system works. Well, I know how to install things, right? But I'm just blindly installing stuff for a lab. What I can do when I'm done installing something like this is I can do RPM QI Samba. Let's do SSSD just there, and I can go read about it, and it says provide a set of daemons to manage access to remote directories and authentication mechanisms. Okay, it provides an NSS and PAM interface towards the system with a pluggable backend. I didn't know what it was doing, but now I know a little bit better right here. Same thing, I might do SSSD dash maybe IPA. What the heck's the IPA? And this provides an IPA backend for the SSSD to utilize and fetch identity data. Well, I could have probably guessed that, right? But the point is, you have a tremendous amount of information at your disposal on top of going out and looking at, blog posts and that kind of stuff. All right, so we've got that part going. Let's enable and turn on the odd job service. We need odd job for doing odd jobs, but mostly like making user directories and those kind of things. And then, we needed to set the auth select for SSSD to allow us to use makedir. All right, so that's good. Let's make sure that odd job is running. Restart and status. All right, odd job's running. We've got all this other stuff set up. We've already done this line here, so I'm going to skip that. And now I'm going to go to my Etsy SSSH, and I'm going to say connect back to SSSD. So in here, this is an empty file. I'm going to drop all this. In your careers, you will probably mostly be putting AD right here, Active Directory, right? Active Directory, Active Directory. I'm also commenting out the TLS part of this because I'm not really concerned with us doing TLS authentication right now, right? SSSD is right here, which services we're going to do, NSS, PAM, and AutoFS. So those are things to go look at if you're not super familiar with them. And then domains, and then home dir substring is /home. You can set that somewhere else if you want this thing to generate home directories for people somewhere else. All right, so we right quit that, and then we have to chmod 0600 on that file. By the way, it will not start if that's not 0600. Your SSSD checks the file to make sure it's got the right permissions. Then we should be able to do systemctl start SSSD. We should be able to do a status on it. We should be able to see that. And then I should now be able to ID test user and see the test user in my system. If I do a systemctl stop test SSSD and do an ID test user, well, apparently I can see it either way now. Oh, it's because he got cached. But anyways, we start him and then we ID the test user, and now we can see the user. And if we can do that, we've now connected our system via SSSD into that OpenLDAP. Because if we were to well, we don't even need cat it. If we grep test user from Etsy pass WD, he's not there, right? But I do see him here coming in from LDAP. So that is the lab. That is a lot, I know, but that is for you guys to spend a little time and mess with this stuff, and then get in there and see some of the security devices, see some of the things connect on your system. And then over here, you also have the ability to look at how the configurations are now working. So I have SSSD running, right? So then I can come over here and I can look at my SSSD and say, okay, in that configuration, do I have offline credentials expiration as equal to 1? Well, I can go check that. I know it's not because I just built a file. But grep offline from Etsy SSSD, SSSD.conf. I don't see that in there. So this is a fail right now. Right? But do I want to set it? Do I want to, this is going to stay open on our system, and that's not good. But can I add that line in? So configure SSSD to prohibit the use of cached authentications after 1 day. So SSSD will try to remember old passwords, and this actually causes a bit of a nightmare in systems for users. So, all right. This is again a little above and beyond the normal course as we go back and look through those things. But as you set these things up, you can go in and you can look at the configurations and see how all of these different things work. Okay, so that is the week 3. Let's go look here and review. We did this is the Linux Security Engineering course. We looked at the relevant STIGs for this. We looked at all the relevant tools. We set up OpenLDAP in our system, and then we connected back to it via SSSD. Then we reported that information. We prepared that system information and put it in a report so that it could be seen by others that were outside of our normal security information. Okay, so that's that. I'm going to go ahead and call the stream here. That is the entirety of the course for this week and what you guys worked on. There is some stuff. Actually, let me show you guys some stuff here real quick. Let me get rid of that. Pull this back up real quick. I'll show you guys a couple things. There is a study group. So for people that are doing the course and trying to keep on top of it, there is a study group that's being run every Friday at 5 p.m. So you guys can get involved in that if you want. We are in week 3 right now, so there's only 7 more weeks of this course, and then this one will be done. And there is the big project, and then you have to be doing the discussions as well as going through the labs and the worksheets if you want to keep doing that. There's a bash study group, and then some other sysadmin stuff. And you know, it's really weird to me. There's definitely something going on with oh, maybe it's because it's in streamer mode, but the Bash study group normally has a pretty cool little picture with it. So I don't know what happened to all that, but all right. So make sure you guys get in there if you want to get involved with that stuff. And then if you have questions, just let me know down in the Discord. All right. So I'm going to go ahead and call this here, and I appreciate you guys coming by, and I will see some of you guys later when we do Lab Sunday, because we just do labs on Sundays, and we'll be just working through Linux and systems engineering. All right. Take care.